Hi everyone, today we're going to be talking about the distance formula and use it to find the distance between 2 points on a coordinate plane. So this is the distance formula. So if I knew a point and another point on a coordinate plane, I could find out how far apart they are or how long this line is. Okay, so in this example, I'm given 2 points, -2, 1 and 1, 5. And I want to know how far apart those 2 points are. Well, yesterday we learned the Pythagorean theorem. Could we use that in this case to find how far apart those are? Absolutely. I could draw a line down and make a nice right triangle. And I would say 1, 2, 3, 4. This is 4. And this is 1, 2, 3. And I could do 3 squared plus 4 squared equals c squared. Now 3 to the second power is 9. 4 to the second power is 16. That will give me c squared. And 9 plus 16 is 25 equals c squared. And last step, square root of both sides. This is 25. I don't know why I wrote 15. And c would equal 5. So the distance of that line is 5 units. Now, this is the distance formula. Let's see if you notice anything about these. See if you see any resemblance between these two things. Distance formula says I'm going to take the square root of the distance between my x's. So in this case, I have 1, 5. And in this case, I have -2, 1. So the distance between my x's would be -2. I'm going to call this one x2. I don't know why. It doesn't matter. And y2. And this one. The only thing that matters is that you just keep track of which one's 1 and which one's 2. So x2, -2, minus x1, which is 1, raised to the second power, plus the distance between my y's, so y2, 1, minus y1, 5, raised to the second power. So my distance equals, don't lose your square root sign, it's very easy to forget that you have that. -2 minus 1 is -3 to the second power, plus 1 minus 5 is -4 to the second power. Then I end up with my distance being equal to the square root of -3 to the second power, which is 9, plus the -4 to the second power, which is 16. 9 plus 16 is 25. So my distance is 5. Notice I get the same answer. And you see some common numbers. Here I have 9. Here I have 9. Here I have 16. Here I have 16. I end up adding those together, getting my 25 and taking the square root of it. Same process. All you're doing here by subtracting the x's is the same as you did here. You're counting the difference, the distance between this point and this point. Same with my y's, my distance between this point and this point. That will tell me the 4. So these are the same thing, just written a little bit differently. And there are times you will not have your graph paper, and so you'll want to use the distance formula, or your triangle may be situated in a more unique way, so it's harder to count the distance. Okay, I want to find the distance between these 2 points. So where is this one? This one is at -4, -1. And this one is at 1, 2. Well, we want to use our distance formula. Distance equals square root of my distance between my x's, -4 minus 1. To the second power plus -1 minus 2 to the second power. -4 minus 1 is, oops, that was a crazy line, -5 to the second power plus -2 minus 1 is -3 to the second power. So I'm taking the square root of 25, because -5 to the second power is 25, plus -3 to the second power, which is 9, or the square root of 34. So do we see that answer anywhere? Well, I do. I see it right here. Square root of 34. Let's look at my next example. Okay, let's find the distance between these 2 points. This one's at -4, +2. This one's at +4, -2. I don't know why I wrote it way up here when my point is down there, but so my distance formula is square root of 2 minus -2 to the second power. And as we know, 2 minus -2 is same as 2 plus 2. Plus -4 minus 4 to the second power. Well, 2 plus 2 is 4 to the second power, plus negative 4 plus negative 4, minus 4 is negative 6, negative 8, not 16, negative 8 to the second power. Four to the second power is 16. 8 to the second, negative 8 to the second power is 64. 16 plus 64 gives me 80, the square root of 80. Well, that's kind of interesting because that's not one of our choices. So what can I do? Well, one thing you do is find the square root of 80, and you find out that that is just under 9. It is, oops, I used the wrong. I had to put things in my computer the wrong order. We all make those mistakes. 8.94, so it's just short of 9, because square root of 81 is 9. Now you might also put this in your calculator. If you put this in your calculator, there's a good chance that this answer is going to show up as your answer, because that is the correct answer. Another thing you could do is, what is the square root of 10? Well, square root of 10 is close to the square root of 9, which is about 3 point something, maybe 3.1-ish, which is not 8.94. It's close to 8. It's 8.94, but it's not 8. And the thing is, we know that one of these distances is 8. The distance from here to here is 8 units. So my hypotenuse has to be the longest length. So it has to be more than 8. Square root of 3 is going to be somewhere around 2 something, which is close to, it's going to be 1 point something less than 2. Square root of 4 is 2. If I took the square root of 4, which would be 2 times 4 would give me 8. So this will be less than 8. So that's not going to work. But like I said, I would recommend just putting it in your calculator, and you'll find that it is exactly 4 times the square root of 5. What they're doing there is they're saying that 16 times 5 equals 80. And I can take the square root of 16, that is 4. But I can't take the square root of 5 without having an irrational number. So that's where that comes from. But if you use your calculator, you will find that 4 times 5, the square root of 5, is the same as the square root of 80. So Lauren traveled from this point to this point, and then she went to this point. And what's her total distance she traveled? So she went from there, way over here somewhere, and then she went way up here. So we don't just want to know what's the distance from here to here. We want to know distance from here to here to here. Well, that's quite a bit. We need to use our Pythagorean or distance formula twice. First, we're going to do this, and then we're going to do this side, and then we're going to add them up. So my first distance, that green one, is going to be negative 1.5 minus 7 to the second power plus my y's, 3 minus negative 3.5 also to to the second power. I have that minus and negative, so that is going to become a plus. I'm going to extend my square root sign so it's all under there. So, negative 1.5 minus 7. That will give me negative 8.5 to the second power. Plus 3 plus 3.5, that's 6.5. Also to the second power. Negative 8.5 to the second power. My calculator works better when it's turned on. It's 72.25. And 6.5 to second power is 42.25. I add those up. I get 114.5. So the square root of 114.5. That was quite a bit of work to only be half done with my problem. Square root of 114.5 is approximately 10.7. So first distance was 10.7. Now let's find her next distance, which is going to be this blue line here. So I'm starting here, going over here. So it's going to be the square root of, I'll say, 7 minus negative 5. I'm going to make that 7 plus 5, because minus a negative, squared, plus, I should have done this one in blue and did this one in green. If I were thinking, I would have done that. Negative 3.5 minus 2.5 to the second power. Extend my square root sign. Well, 7 plus 5 is 12, so I have 12 to the second power. Plus negative 3.5 and negative 2.5 is negative 6 to the second power. I believe that's right. For some reason, I'm doubting myself. Hey, yep, I'm right at negative 6. So I have the square root of 144 plus 36, which would give me the square root of 180, which again is not a perfect square. So the square root of 180 is about 13.41, approximately 13.41. Since I rounded this one to 1 decimal place, I'll round the other one to 1 decimal place also. So 13.4, 10.7. To answer my question, the total walked would have been 24.1, whatever units these are. Walks, miles, 24 miles would be very far. It says the endpoints of AB are 5, 1 and -6, -5. The endpoints of CD are -6, 5 and 3, 5. How much longer is AB than CD? Well, let's see what those look like. AB is 5, 1, 2, 3, 4, 5, 1, and -6, 1, 2, 3, 4, 5, 6, -5, 1, 2, 3, 4, 5. So these are my endpoints of AB. That's not 5, 1. I don't know why those points are there. Those are wrong. My points are right. So I'm going to connect my points. It's not on 1. And then I have line line CD, which is at -6, +5, 1, 2, 3, 4, 5, and 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. Well, the nice thing about the second one is I don't even really need to use my distance formula. It is a horizontal line. I can just count it. This one's 9 units. So I really only need to find the distance between these 2 units. So, using my distance formula, I can do 5 minus -6, which becomes 5 plus 6 to the second power, plus 1 minus -5, which becomes 1 plus 5 to the second power. Well, 5 plus 6 is 11 to the second power. And 1 plus 5 is 6 to the second power. 11 to the second power is 121. 6 to the second power is 36. 121 plus 36 is 157. And the square root of 157 is 12.53 approximately. So how much longer is this one than this one? Well, that would be approximately 3.53 units. 12.53 minus 9. I don't know why those lines are so crooked. Okay, for this one, I want to know the area of a triangle. If you remember how to find the area of a triangle, it is 1/2 base times height. Do I know the base of the height here? No, I know the height. remember the base and the height form a right angle. So this would be my base or my height. I can call this my height. How's that sound? We'll call this my height. But for some reason I was picturing it sitting on this end, but it's just sitting nicely on this end. So I'll call this my base. But I don't know this. So can I use my Pythagorean theorem to find out my height? Absolutely. This is my C. I'll stick with this as B, even though it was B for base. It's going to be B for leg B now, which make my height leg A. So A squared plus B squared, and my B is 7, will equal C squared, and my C is 9. So A squared plus 49 will give me 81. I think my handwriting's getting worse the longer I go. Subtract 49 from both sides. And I get A squared equals 32. And my last step will be to take the square root of both sides. And my A will be 5 point something, but I don't know what, so I'm going to take the square root of 32. .65 approximately. Actually, it would probably round to 5.66. It's a little closer to that, so I'm going to do approximately 5.66. So if this is 5.66 feet, my area would be 1/2 times base times height. And 1/2 times 7 times 5.66 equals 19.81. So it's going to be approximately 19.81 square feet. So that's it. Have a great day. Talk to you soon.